Hello, college algebra student. This video is for chapter 4.3, part 2, the last example of linear regression. So just one more example on how you can find an equation between two variables when you have collect some data and then figure out that they are linear and then do a model. So here, this question is the relationship between price and demand. So maybe the manufacturer actually had tried, if they set the price to 150, the demand is this. And if they can control the demand by increasing the price. So all of a sudden the demand drop, right? So, but is this drop linear? So what they did is they plot the data. They collect the data and we're going to plot it on a scatter plot. So I have the scatter plot enter here. This is all the price, 150, 208 to 250, 175,000. So remember, this is in thousands, not 208 item being sold. And I zoom in, zoom fit. So this look like a linear function, negative. That means when you increase price, the demand drop. There is a particular point that doesn't line up, but all of them line up pretty good. So you can be confident that you can model it by a linear model. So let's look at what the model look like. So y1 weekly mx1 plus b. So the slope is negative 0.357. So and then b is 264.429. Let's go back to our example things. So we want to find the linear model. So we have the linear model. Want the slope to round the slope to 2 decimal places and the y-intercept to whole number. Write s as a function of p. So just make sure that s is the second one, y, right? S is y, the demand. Function of p. So p is the input price. So we would write function of p. So we can say, let me get my pencil up. So we need p of, we need write s as a function of p. So it should be s of p. So the function of the demand basing on price would be equal to negative 0.36x plus 264. Oh, this is not x, it's the price. If I have this 4, this is not. There's nothing. There's something from the O's writing to 368. Okay, 264. Okay, so this is the directly from decimal. Look at it again. 264 round to whole number, negative 0.36. So if I plug in price, it would tell me what the demand would be according to the model. So according to the model, what should the price be so that my weekly demand is 199,400. Now, because if you look at the data itself, the demand is set in thousands. So notice that it is in thousands. So when they say 175, it doesn't mean the 175 itself is 175,000. So if I have 199,400, that is equivalent to S is equal to 199.4, right? And I want to find what price would it be. So I don't know the price. That means this is unknown, but I know S. So you're solving it the other way around. You're solving 199.4 on this side equal to negative 0.36p because you don't know p plus 264. So you minus 264. Get some more space. Or you minus 264 on both sides. Negative 0.36p. So sometimes you use it to predict demand, but in this case you have a demand in mind and you want to use it to find out what price you would do. So 199.4 minus 264. So it's negative 64.6 and then divided by negative 0.36 on both sides, divided by negative 0.36. So P would equal to divided by negative 0.36, 179.7, 0.44. So if you set this price, your demand would be that much. Okay, so price at 179.44 will result in demand of 199.4 thousand. So just you need to pay attention that this is your equation is quoted in thousands. So if you actually have the whole number device, you have to change it into thousand. That is 199.4. Okay, so that's the end of this example. That's the end of actually 4.3.